This is lesson 2 in IM. For the notice and wonder, anything you say is correct because it's what you notice and what you wonder. If you were to solve these equations, you would get 329 from how many boxes there are total. 10 squared is not 10 times 2, but it is 10 times 10. So 10 squared does not equal 10 times 2 because 100 does not equal 20. 10 to the first is the same as just 10 by itself. If there is no exponent, you can write a 1, but you do not have to. 10 to the 0 is 1. When I tell you to start counting, you normally start with 1. Anything to the 0 power, it doesn't matter what it is 1. 1 to the 0 power, 1. 1 million to the 0 power, also 1. Okay, so anything to the 0 power is 1. That's it for 2.1. For 2.2, when you are evaluating, you are replacing these x's. So if you take x cubed, x squared, and just the regular x, and you replace it with the numbers it gives you. So with this -5 first, we'll replace, and then we can do it again with this +15. Now, as we go through, if you need to pause to do this yourself, or you want to follow along for one and try the other, please do that. That will definitely help you, and you can use me to double check your work. So I'm going to have 5. Well, let's start with p of -5, because p is the function name, and I am plugging in this -5. So p of -5 equals 5 times -5 cubed plus 6 times -5 squared plus 4 times -5. You can put this part into the calculator. If you have like a nicer calculator or one that you know for sure is going to follow order of operations, do not include this p of -5 and the equals, because it will not help you ultimately. When you are plugging it in, just do that last part. If you want to do it step by step, like how I'm going to do it, I'll walk you through it. All of the time, I'm going to step by step. If you feel confident that you are not going to forget something, you can definitely skip some of these steps. Okay. So when I do this, 5, -5 cubed is -5 times -5 times -5, which is -125. Okay. I keep my 6. -5 squared, any number squared is going to be a positive number, because a positive times a positive is still a positive, and a negative times a negative is also a positive. So that's 25. Now, I can do this, but for right now, I'm going to leave it so that they're all in parentheses. 5 times a -125. A positive times a negative is still a negative. So I have -625. Okay. 6 times 25 is 150. Think about if you have 6 quarters, that's $1.50. Okay. 4 times -5 is -20. When I put this all into the calculator, as I am doing right now, you want to see right now, I need to make my 625 negative, and I am adding 150 and subtracting 20. As long as you keep the signs the same, the order doesn't matter. Okay, it's -495. So we can say that p of -5, when you plug -5 in, it's going to equal that -495. Now you can do the same with the 15. It's going to look very similar. Here, p of 15. If you start with a positive number, if you cube it, square it, take it to the 6th power, whatever, it will always be positive. But I repeat the process. Now this one might be a little harder to do in your head if you are somebody who likes to do that in their head. So 15 to the 3rd power is 3,375. 15 squared is 225. And again, I'm going to leave that 15 in the parentheses just for the sake of being consistent. When I then go through, I'm going to multiply it again. So I have 3,375 times 5 gives me 16,875. 225 times 6 is going to be 1,350. And then I am adding this 4 times 15, which is 60. So when I put all of these into the calculator, I get 18,285. And again, that's P of 15. Okay, so this next, solving. Because they all have the variable x, they are all going to be the same value. So you can break it up into pieces because they also equal the same. You can say 5x cubed plus 6x squared plus 4x equals 5,000 plus 600 plus 40. And there are going to be multiple different ways you can try this. What I like doing is because I can see the 5, 5, 6, 6, 4, 4, and they all have these zeros, I have a hypothesis that they're going to be similar. So I could say 5x cubed is going to be 5,000. And 6x squared is going to be 600. And 4x is going to be 40. Now I'm going to double check this before I just go through and say, oh yeah, that's the answer for one of them. I want to make sure it's consistent for all of them. So 5x cubed, if I divide both sides by 5, that gives me x cubed equals 1,000. The opposite of cube rooting something, haha, I just said it. The opposite of cubing something is cube rooting. So I'm going to cube root both sides because when we do the opposite, it cancels. So this 5 and this 5 left me with just the x cubed. This cube root and cube cancel, so I'm left with x equals. The cube root of 1,000 is 10. And this is because if I took 10 cubed, that's 10 times 10 times 10, which is 1,000. I can follow the similar process here, dividing both sides by 6. I get x squared equals 100. I'm gonna actually leave room for my square root this time because I'm gonna square root. Technically, you can write a 2 there if you want. It's not wrong if you don't. It's not wrong if you do. These are gonna cancel, which leaves me with x, and the square root of 100 is 10, because 10 times 10 is 100. Last time, divide both sides by 4. I just get x equals 10. Now all three of these do give me the same value. And I can double check that. So if I plug in 10 here, and 10 here, and one more 10, I would get 5 times 1,000 plus 6 times 100. And just like earlier, I'm going to keep it consistent and leave my 10 there for now. I get 5,000 plus 600 plus 40, which does give me 5,640, like I wanted right here. So that is how you can solve it. Always doing the opposite, and what you do to one side, you must do to the other. What I mean by opposite is 5 times x cubed, so I divided. X times x times x, so I split that into 3 parts. Then we get to 2.3. If you are a table person, I strongly recommend that you use a table for this because you are going to be consistently adding more and more money. I do not have a lot of room on this page, so I think I'm going to write it down here. Okay. She's depositing 300 in her senior year. Okay, this is investment money. You can use it for whatever you want. She's going to college. This could also be if you wanted to buy a house or a car or anything like this. Okay. R is the interest rate. Interest is good when you are saving money. It is not so good when you're thinking about having to pay back loans. I'm gonna make sure I actually highlight this, interest rate. So interest is good when you save money, bad when you have to pay the money back. Okay, well, good for the people who want it, bad for you. they're telling you that x equals this 1 plus r. This is because 100%, when you write it as a decimal, is 1. The interest rate, for example, if you do a 3% interest rate, 3% is 0.03 as a decimal, and you have to add that to your 100%. This is why it's split up like this. This 1 plus your interest rate. 1 plus your interest rate of 3% is 1.03. That 100% gets you back up to the original amount, and then this 0.03 gives you that additional. Okay, I kind of jumped ahead just a little bit to help organize. I'm going to create this table because each piece adds another part to it. So after 1 year, the total is 300x. So she deposited 300 to begin with. So the first deposit was 300. So when she's a senior in high school, senior, and then these 4 are college level. When she is a senior in high school, she deposited $300. After 1 year, it's 300x. So at the end of her freshman year of college, it's 300x. Right there. After 2 years, it's 300x squared, because 300x times x. You have this interest rate of x for 1 year, 2 years, because it's going to continue to accumulate. So this 300x squared is going to go right here after 2 years. So this is 300x squared. This adds a part to it. She is investing another $500 at the end of freshman year. So not only does she have that 300, but she's now going to add this 500 into it. This has accumulated interest for 1 year. This has not. This has an X, this does not, so they cannot be combined unless we know for sure what the interest rate is. So then for sophomore year, we had this 300 interest rate twice, because for senior year and for freshman year, well, technically freshman and then sophomore since it's happening at the end of the year, you're adding your 500, but now this 500 has accumulated interest for 1 year. Because it was here, it's now been a year, it has a year's worth of interest rate. It now starts to tell me that 250 is invested at sophomore year. So now I'm going to add this 250. And I am running out of highlighting colors, so you might need to start doing shapes or something like that. I'm adding that 250. And then it says 400 at the end of junior year. And it doesn't talk about senior. Okay. So I'm going to take all of these and I'm adding 1 more year's worth of interest rate. So this is now going to be x cubed. This is going to be x squared because I had 500 for 1 year for 2 years. This 250 has now accumulated interest for an additional year. But now I'm also adding 400 at the end of junior year. So this 400 is right here. All these expressions are written right here for each question. And it says after 4 years, her total is 1580. Okay. I don't have a graphing calculator with me, but what you can do is you can solve this. So you have 1,580. You have 300x, and this is going to be at the end of senior year. So I'm going to add 1 to each one because it's gone 1, 2, 3. This would be my 4th year. my third year for the 500, my second year for the 250, and 1 year for my 400. If you were to solve this, you could find what x is. You can guess and check, you can graph it, you can try to factor it if you know how to factor. I'm going to go ahead and tell you that it is that 1.03 we talked about earlier. So if you were to plug in this number for all of the x's, you would get 1,580. It is a little more difficult to guess and check, but if you graphed one line as y equals 1580 and your other line as this equation down here, this part, you would get where they intersect, which is at 1.03. There might be some rounding, which means your number is not going to be exactly perfect. But this also shows you that investing is a really good opportunity, because even if you just left this 300 and let it sit there for 4 years at a 1.03% interest, you would still have more money than you started with, and that's something that's like passive income. Okay? So that is 2.3. If you look at these practice problems, this one is very similar to what you just did, where you are writing and your interest rate is 1.02 because this 2% is 0.02. When you put it as an interest rate, you're going to use 1.02. But you can use this as practice for that last one. So this is good practice for 2.3. This is good practice for when we solved in 2.2. And up here is really good practice to remind yourself what you can and cannot divide or combine. I'm sorry. If you look up here, you can only combine like terms. So they either have to be x to the 4th, we have none, they can't combine. X cubed, we have none, they can't combine. X squared, there are no more, just x, no more, and our constant. Looking at these, they're just changing the order. Well, this is 6x to the 5th, that doesn't work. This looks like they might have combined all of our numbers, we can't do that. Here, 6x to the 4th, 4x cubed minus 7x squared plus 5x plus 8. It's in exactly the same order, nothing is combined, that one's good. Here, they changed the order. So this is what's called standard form, where you write it in your highest exponent, your degree term first. Your leading coefficient is right here, and down to your constant. So 4 is your highest exponent. You work your way down. That is something you're going to need to know. So degree is your highest exponent. Your leading coefficient, I'm going to write it out this time. You'll probably never see me write it out again because it is longer. I normally write it as LC, is the number in front of your highest exponent. So your degree is 4, your leading coefficient is 6. So number in front of degree. And you do not include your x with that. And then your constant is your number without a variable. And you do include if it's negative or positive. In this case, it is 8. 6x to the 4th minus 4x cubed. Because that sign is different, it automatically disqualifies it from being the same. 6x to the 4th, 4x cubed minus 7x squared plus 5x. And even though there is no sign here, if there is no sign, it's a positive because all of the signs and numbers matched. This one works too. So again, these are some vocab words you're going to need to know. They help you with shape of graph, your y-intercept, your end behavior, and a whole bunch more. Standard form, again, is highest exponent, and you work your way down to your constant. If you write it in standard form, your degree is your first exponent you're going to see, your leading coefficient is the first number you're going to see, and your constant is the last number. If there is no constant, so if this 8 didn't exist, the constant would be 0. If your leading coefficient doesn't exist or your degree doesn't exist, they are both 1. What I mean by that, if I just have x minus 8, my leading coefficient is 1, my degree is 1 also, so I could write a 1 and a 1 if I wanted to, and my constant would be negative 8. If, however, I had x cubed plus 4x and that was it, my degree is 3, my leading coefficient is 1, my constant is 0. Okay, so this is really good practice for 2.3. This is really good practice for 2.2. If you want to double check your answers, you can look online at IM. You can try to match it up. I will potentially make a video for that later. We will see how that goes. All right, that is lesson 2 for IM. Okay, we're back to double check our practice from 2.3 and our practice for 2.2. So the practice for 2.3 is when you're depositing money and you have your interest rate. For the first part, we don't know what the interest rate is. We just know that we have our 100% plus our additional interest to increase that monetary deposit. So we have 500 here from our first year. Because it's the start of first year and we're doing it for 3 years, we have our interest rate 3 times because x times x times x is x cubed. The second year we deposit 200 and we will have 2 more years for that, so it's x squared. The last year we have 600 and it only accumulates for 1 year. Down here we actually know what our interest rate is. It's 1.02. When we do this, if you round sooner than I did, your answer might be a little different. This is the full value of 1.02 cubed. You could definitely round. Because we are doing cents, you would round to 2 decimal places. I have $530.60, but technically it was 0.604, plus $208.08, plus $612. Each year is going to be different with interest rate. So when we add 530.6 plus 208.08 and our 612, our total is going to be $1,350.68. So that was the practice for 2.3 where we had our nice table over 4 years, well, 5 years. Okay. This one, when x is -2, I am replacing all of my x's. So my x here, here, and here with -2. So I can rewrite that. I'm going to have 5 times -2 cubed plus 8 times -2 squared minus 3 times -2 plus 1. Okay. -2 cubed. Any negative number cubed will remain negative because the negative times a negative is a positive, but that's only 2. So then you have a positive times a negative, which will bring you back to that negative. And 2 cubed is 8, because 2 times 2 is 4, times another 2 is 8. Any negative number squared will be positive, and 2 times 2 is 4. And then a negative times a negative is a positive, but for now I'm going to leave this here, and then we'll come back to replace it. 5 times -8 is -40. 8 times 4 is a positive 32. Now here's where we change our sign. That's a 6 and a 1. Okay. As long as you keep the signs the same, the order doesn't necessarily matter. You can group them, you can do them all at once. If you have a nice calculator, you can put them all in at once. But I'm just going to double check my work. Your answer should be -1 when you get all of that done. So you can write that P of -2 equals -1. What that means is that when you plug in -2, your answer is -1.